Assalamu alaikum. Today we discuss about this mechanical problem, this very important problem. Okay, let's start. A on 20 A 50 kg crate attached to the trolley beam and showing the knowing and the A equal to 1.5 meter. That's A is the 1.5 meter and determine A is tension. We have to determine the A tension. That means it's CD tension. This tension we have to find out. This means T. And number B, the reaction of the B. Yes, here is the reaction B we have to calculate. This is the main point. Okay. At first, we will draw this free body diagram. This free body diagram, as we were looking at, this tension is acting this way and can this way. We don't know. We can assume any direction. Okay, we are considering this way. Okay, here is the pin joint. Here pin joint. This pin joint is acting on the upper direction and also reaction in this direction. We are considering Bx and is the By. Okay. By this way, we are drawing this free body diagram. Here is the distance is 0.4 and 1.4. Here, after drawing this free body diagram, we are looking this the tension and also this, and this is the 1.4 and this one is the 0.4. Here, what is the this is unknown Bx and By. Also, this is T is the unknown. Here we are looking in the free body diagram where is the more unknown point. This unknown point is the Bx and By. So we have to put in this point is moment equation. So we are considering here is clockwise is the positive. Clockwise equal to is positive because we know the equilibrium condition for 3 and summation moment equal to 0. Just we are applying the moment in B point equal to 0. Then this cos 30 degree. How it's come? Here is looking is the resulting force, but here acting the two forces. Here is the in x-axis we are considering T cos. Also here is given 55 degree, and after calculating we are looking here is the 35 degree. So by this we'll put here is 35 degree. But here moment we are considering here when we apply this, here is perpendicular distance only this 0.4. So this perpendicular distance is 0.4. Okay, T cos 35 and 0.4, and then the T sin 35 here is very crucial point, and here is the very crucial point we are looking here. Here is the T sin 35. T sin 35. Here is the T sin 35. See 35. But here is the perpendicular distance y 1.4. Y 1.4. Because if we look here, is the this is the rectangular. Here is this one is the T. But we don't know that this here is the gap, but we don't know this value. So we have to find out that this total distance, this from this distance. So that's why we can apply the formula of the tan theta. Tan theta equal to, that is the is perpendicular is the 1.4 and distance 1.4 and distance if we consider B to C, then BC, then we can write here BC equal to 1.4 divided by tan 35. Okay, that one is the perpendicular distance from T sin 35. Another is the this. When we consider, if we consider this one is try to move is clockwise. That's why we have to consider the positive, and that's why it has been it will be positive. But this direction is try to this anti-clockwise, so it will be the negative. This one the negative sign. So negative sign, and weight is the 50. Here weight is 50. Weight is 50. So we will put the Newton for 9.81 will be multiplied and into the perpendicular distance. What is the perpendicular? A amount of A has given 1.5. After putting this, then we will get the T equal to 500.8 Newton. Okay, now we get the T, our desirable value. That means ATCD we have got. That means one answer. And number two, then number two, we have to find out the B. We have to find out B. Summation of Bx equal to 0. Here we know this one. We have unknown two value, the by and bx. So just we will sum of we will consider this right hand direction is the positive and fx equal to 0. Then bx, this bx is the going this equal to that. This direction equal to this direction equal. Also we can write after simplifying we get that this. Okay, is the same. This one is the positive. If we consider this one is the negative, but this one is the positive. Both is in equilibrium condition is the equal. That's why we can write here bx equal to t cos 35, and then we'll get the bx value. After summation of fy, if we put in the y direction equal to 0, then how which weight is acting. This is the y direction, and also this is the y direction. Also here is the fy direction. These three value is acting in perpendicular. Okay, then is the we just put w. W is, if we consider this one positive, if we consider this in downward direction is the positive, then down direction, okay, downward direction is a positive, then w is acting in downward direction, and w is positive. Sign t sign is acting the up direction is negative, and by also this is the negative. Then we'll get this, and then we'll get the by value. Okay, and then reaction at the B. Then B, just put over this formula, Pythagoras formula, and then we'll get the B reaction force is this. But what is the angle of that? Because we have got the two value according to x and y, then we can easily find out the theta cone, theta angle. So theta equal to tan inverse and 223.2 divided by 410.2, then we'll get the 26.35. This you got this answer. You have understood each and every word.